In this video, we're going to be drawing heating and cooling curves for water, but these curves can apply to anything. So the heating cooling curves, they look like a series of steps. We've got the steps going up and we've got the steps going down. The ones going up would be called the heating curve because as time goes on it gets hotter, and the reverse is true for the cooling curve. We've got temperature on the y, time on the x. The time itself doesn't really matter for this curve because we're just doing a basic drawing. It's really just about identifying the different parts. When you do this in a lab or things like that, then the time may matter. You know, there may be increments on the time, but I'm really keeping the increments. For the most part, we're not going to write any of them in because we're just working on identifying stuff. So the first things that I like to label when doing these are going to be the flat parts. All right, so now if we think about what's going on, for the heating curve, we have the first flat part is going to represent the melting point, and then the second one would be the boiling point. Now, boiling point, you could technically also call it the condensation point, and the melting point can also be called the freezing point. But most people just call it boiling point and melting point. It's just easier. And for water, it would be specifically 100C and 0C. Now, that's water, obviously. This curve can be applied to anything. So one thing to keep in mind is if it's not 0 and 100, then it's not water. Those are the main melting points for pure water. Obviously, we can change those melting points if we're not dealing with pure water, but for pure water, it's 0 and 100. And then for here, it would be the same thing. This would be 100. This would be 0. All right, and so those are our boiling points and melting points. Now the next part is going to be the phases. Those are the next easiest thing to label. So when water is below freezing, it would be a solid. So this would be my solid water. And if I were to do a phase diagram, it would be a repeating geometric pattern. You could fill the whole thing or not, it doesn't matter. So there's my phase diagram. Above the melting point, the water would have melted, and so therefore it would be turned into a liquid. So there's my liquid. Now for the liquid, I just randomly put a bunch of circles to represent my water molecules, and I like to only fill the box about halfway. And we try to keep them relatively close together. If you filled it the whole way, it wouldn't necessarily be wrong as long as it's not in a repeating pattern. And then when you're above the boiling point, you're a gas. So those, I spread them out. I don't use as many. I fill the whole container because gas particles are really far apart. That's how you just, and they're totally random, but the real difference between the liquid and the gas is the distance between the particles, and the gases will always fill the whole container, whereas the liquids, if it's only half filled, then they only fill half the container. All right, so there's solid, liquid, gas. Now we would also do the same on the reverse. So we've got gas, liquid, solid, and our phase diagrams would be the same thing. Randomized, fill the whole container. Closer together, but also randomized. I only fill half the container. Repeating, geometric. Sometimes they use the word geocentric, but the same idea. Repeating geometric pattern for the solid. So there's my solid, liquid, gases. Next part, let's talk about the phase changes. So we know those. When a solid turns into a liquid, so in other words, if we're going in this direction, we would call that melting. The scientific word is fusion. All right, the reverse of fusion is freezing or solidification, so we don't even have to think about it. Once we identify fusion, we know the other side is solidification, and we can do this here too. Now, there's two ways of doing it. Some people like to keep the arrows in the same direction, the top and the bottom, but you could also flip them, it doesn't matter, so I'll show you both ways. If a liquid turns into a solid, so if we're going in this direction, this would be solidification, and then the reverse is fusion. Now, I don't care how you label it, meaning if I put the fusion on top, the arrow would just have to be pointing to the left here, and if I kept solidification on bottom, the arrow would still have to go to the right. So as long as the arrow matches up with the proper word that's describing the phase change, and it doesn't matter which one you put on top or bottom. But also the nice thing is, as long as you know one, like if you just know fusion is melting, therefore solidification, you can just flip it. It's not hard to memorize them both, but it's one less thing you have to memorize. Now for boiling, boiling is when a liquid turns into a gas. So vaporization, same thing here. It would be, I'll flip it just to show that it doesn't matter. So there's vaporization. So if you notice, I kept it on top both times in this example. I just changed the arrow, so that's totally fine as long as you have the word and the arrow that matches. It doesn't really matter. And then the reverse, condensation. So those are pretty easy. That's most of a heating cooling curve. And then the last things we have to worry about, I guess I'll switch. I don't really need to switch color on these, but we're going to talk about the firsts and the lasts. So the firsts and the lasts show up on the corners, right? So I'm just going to, you don't have to put a dot here. I'm putting a dot to make it more obvious what I'm talking about. So we have what happens there, first there, there, and there. So the corners. So now if you think about what's happening, right here we have a solid block of ice. Its temperature is in the negative Celsius at some degree. I don't care how negative it goes, but as it's warming up, when it initially hits 0 degrees, that's when melting begins. So visibly what you would see is the first appearance of a liquid. So we would say that at this corner is when the first liquid shows up. Then now, when we're on this flat part, the ice cube is getting smaller and smaller, and the amount of liquid water is increasing, and so the ice cube gets smaller and smaller and smaller until at this very last corner is when the last piece of ice disappears. So that's when your ice cube formally, officially, fully disappears from view. You can't see it anymore. That's that corner. And then the next corner, again, now we have liquid water, and we're heating it up. When it gets to 100, it begins to boil. That's when we see our first air bubbles, usually at the bottom. Well, not air, but first gas bubbles. They're usually at the bottom of the pan if we're boiling water, things like that. And now, if we're boiling the water on this flat part, the water is evaporating into the air or vaporizing into the air, and you're going to have less and less water. Eventually, all the water is going to be gone. So this is when your last little drop of water finally vaporizes into a gas. So there's your firsts and lasts. Now, if that was hard, watch, there's a much easier way of remembering it, so hopefully this makes it a little bit easier. I like to do it, it's always the way we read, left to right. First, last. They always go first, last, first, last. So if you notice, on this side, it did the same thing. First, last, left to right, the way we read. And for cooling, it does the same thing. First, last. So that gets rid of that. You don't even, that part of it, you don't even have to memorize. You just know it goes first, last, and the whole thing is done. And then the question is first what and last what? It's always the phase on the opposite side. So in other words, on this side, I'm on the gas phase. Like this is gas, I'm on the side of the gas. So this would be the first appearance of liquid, because liquid's on the opposite side. Now I'm on the liquid side, so the opposite would be the gas. So this is last gas. This one would be first solid, because the opposite side is solid, and this would be last liquid, because now I'm on the solid and the opposite side is liquid. You can also talk your way through it. If you think about it, you have a really hot gas here. It's starting to cool down. Eventually it will start to condense. That's the flat part. It will start to condense, and the way we know that it's starting to condense is we will see our first drops of liquid appear, like on the glass or on the container or whatever. We'll see some liquid show up. That's why it's first liquid. Now the gas is condensing, so we're going to have less and less gas and more liquid. Eventually it will finish condensing, and that's where the last bit of gas turns into a liquid. That's obviously invisible to us, but you can imagine it in your mind. That's what's happening. And now we have a total liquid, right? And so the liquid's going to get colder and colder. Eventually it's going to hit 0 and begin to freeze. That's where we see our first pieces of solid ice showing up. And now as we are doing this, the liquid is becoming more and more solid, and it's becoming more, well, more solid, more ice, less liquid in this case, and eventually it'll be done freezing. That's this other flat part, and therefore the last bit of liquid will disappear. So that's pretty much a heating cooling curve. There are two more things we have to know, and then we're done. So I'm going to draw them like this and like that. So basically the endo and exothermic directions. There's a saying, I want you to write it down. When you exit a building, you go downstairs. Now, obviously, it's not always true. If you're in the basement, you're going to go upstairs, but it's a generalization, and it's really just a device for remembering which direction is exothermic. So if you think about it, exo and exit, they both have the EX in it, so therefore the exit direction is always down the stairs. So if we think about the down, if we're talking about the heating curve, down would actually be to the left, so this is the exothermic direction. And if we think about a cooling curve, the down would be to the right. So that's the exothermic direction. It's always down the stairs, and whichever way happens to be down. And then the reverse is exothermic, or endothermic, sorry. So that is a fully labeled heating and cooling curve. At some point, you will eventually get a quiz on this. The quiz will effectively be a blank one. The only thing you will get is the sketch of the curve, and then I will put in, instead of, S, fusion and solidification, and L, I'll put in, number 1, number 2, number 3, number 4, and all the firsts and lasts and all of it, and you'll have to label and tell me what everything is on your own. I do want the scientific words, not the common words. So I don't want to see melting and freezing. I want fusion and solidification. I don't care if you call it melting point or freezing point or boiling point or condensation point. They mean the same thing because they happen at the same temperature. They're just reversed directions, meaning melting is when a solid turns into a liquid and freezing is when a liquid turns back into a solid, but that's essentially the same thing. It's just energy going in or out. So that is the fully drawn heating cooling curve.